Please title these notes Application 6 Notes, More Accumulation, and write today's date. By the end of this lesson, you should be able to calculate accumulation from piecewise functions and when there is both input and output. Let's start off with the piecewise functions. Remember, a piecewise function just has different equations for different values of t. So for this one, the rate at which oil is leaking from a broken pipeline in barrels per day is given by L of t, that's for leak, equals 2 when 0 is less than or equal to t is less than 3, 0 when 3 is less than or equal to 2, which is less than 10, and 3t when t is between 10 and 14. And t is time in days since the leak began. So our first question, how many barrels of oil have leaked by the 14th day? So what we're looking for here, this is again accumulation because we're given barrels per day and we're interested in the number of barrels that have leaked. So we're interested in the integral from 0 to 14 L of t dt. And the only thing that's different about a piecewise function is that we have to break this integral up into these different pieces. Because we've worked with piecewise functions before in graphs. Piecewise functions are just functions that look something like this. So here's at 2, then it drops down to 0, then it goes up to being 3t. Actually, it doesn't look quite like that. That's more like it. And what we did is we just found the area of each piece and add them up. And so we're basically doing the same thing here. The area is just the integral. And we've got one piece defined from 0 to 3. We've got one piece defined from 3 to 10. And we've got one piece defined from 10 to 14. So all we need to do is do each of those. You can either do it by hand or with a calculator. This one, the integral of 0, it's this piece right here. The rate of change is 0. So there's no area under the curve. The integral of 0, regardless of the numbers, is always 0. Okay, so 2 times 3 minus 2 times 0 plus 0 plus 3 times 14 squared over 2 minus 3 times 10 squared over 2. That's going to be 6 plus over here this is 294 minus 150. 150, make sure you have units. Barrels. On a similar note, we can also ask, what is the average rate at which the oil leaks over the first 14 days. Remember, average value. We're going to have this little division, so from 0 to 14, so we're going to do 14 minus 0. Integral from 0 to 14 of L of t. This is going to give us the average value of L of t. We just calculated this up here. Or approximately 10.714, always do at least 3 places after the decimal, barrels per day. Remember, average value units are always the same as the original function. We can also do accumulation in situations where we have both an input and an output. Water is flowing into a pool at a rate of I for in of t equals 15 gallons per minute. It is leaking out at a rate given by L of t equals 5 sine, make sure you're in radians, pi over 5t plus 6 gallons per minute. And here's first question. How much water is in the pool at t equals 10 minutes if there are 100 gallons in the pool initially? Okay, so if we just think about having a pool and think about how much is in there, the amount in a pool is going to be whatever we started with, plus however much we put in, minus however much we take out. So we can say that's the initial amount plus amount in minus amount out. And both of these, the amount in and the amount out, are accumulation. So we are told the initial amount, they're initially 100 gallons. Accumulation, well, if we look at what's flowing into the pool, from the start to 10 of 15, and then we're going to take out the amount out from 0 to 10. This is 5 sine pi over 5t plus 6, because that's the total amount that leaks out if we look at these things separately. So, if we just go ahead and put those in our calculator with finite integral, Math 9, 15, comma, t or x, whichever you want to use, comma 0, comma 10. That's 150 gallons flow in. And then make sure you're in radians. That's mode. Yep, in radians. It's all good. Math 9, 5 sine of, whoops, that's not, there you are, pi divided by 5, need another parenthesis, times t plus 6, variable is x from 0 to 10, 60. So 100 plus 150 minus 60, that's 190 gallons. We can also be asked something like this. At what rate is the volume of the water in the pool changing at t equals 5 minutes? Well, our overall rate of change is the rate that the water is flowing in minus the rate that it's flowing out. And these we're told. We don't have to do any integrals with this. We just have to look at our problem. In, that's I of t. Out was L of t. So the rate in was 15, and the rate out was 5 sine pi over 5 t plus 6. Rate at t equals 5 is equal to 15, and then we just substitute 5 in for t. 5 times the sine of pi over 5 times 5, which is going to cancel out, plus 6. Sine of pi, remember, the xy coordinate point of pi is negative 1 comma 0. Sine is the y value. Oh, there's one thing I forgot. This whole rate out should have parentheses around it because we are subtracting this 6 in addition to subtracting everything else. So this is all sine of pi is 0. So we have 15 minus 5 times 0 is 0. 0 plus 6 is 6. 9, and then our units are the same. We didn't do any multiplication or division that would change the units, so it's just the original units that we had for the rates, gallons per minute. And there we go. Let's do one check for understanding problem, and then we'll be done. Over the course of a day, a sprinkler accidentally waters a sidewalk. Actually, I think I said a parking lot. At a rate in gallons per hour given by R of t equals 8 minus t when t is between 0 and 8, and 0 when t is between 8 and 24, where time, t is the time in hours starting at 7 o'clock a.m. Water evaporates from the parking lot at a rate of E of t for evaporation equals 2 when t is between 0 and 16, and 0 when t is between 16 and 24. How much water is on the parking lot at time t equals 10 if there is no water initially? Okay, try that one on your own. Pause the video and restart the video when you're ready. Pause the video now. Okay, so to solve this one, the total water on the parking lot is going to be the initial amount of water plus the amount added minus the amount evaporated. We're told that there's no water there initially, but we do have water that's being added. So from 0 to 10, we're going to be taking the integral of r of t dt, that's our amount added. Then we're subtracting the amount that evaporates, so that's the integral from 0 to 10 of e of t dt. Notice that these are both piecewise functions, so we have one function going from 0 to 8, another function going from 8 to, and we'll stop at 10. So that means that this is going to split up into two different functions. One is the integral from 0 to 8, and that function is 8 minus t. And the other is the integral from 8 to 10, which is just 0. This one, however, has the same function from 0 through 16. That's further than 10. Since we're stopping at 10, we're only going to be using this first piece. Okay. This we can just use the finite integral for, math 9. 8 minus t, or x, same variable from 0 to 10. Try that again, that's 0 to 8. Okay, so that's 32. The integral of 0 from anything to anything is still 0. And then the integral of 2 from 0 to 10, you can do that one in your head, but do check on the calculator to confirm. $20. So when we add those up, 32 minus 20, 12 gallons. That concludes these notes.